With the rise of accessible and affordable large language models, blind and low vision users can now independently tackle visually complex and creative tasks, such as image editing and programming, that once required sighted assistance. However, highly intricate visual spatial workflows, such as three-dimensional, 3D modeling, which usually involve complex visual interfaces and operations, are still challenging for BLV users. We introduce A11yShape, an interactive system designed to help BLV users who possess basic programming skills understand, modify, and iterate on 3D models. A11yShape consists of three main interactive panels. The code editor offers BLV users a fully accessible, standard text editing interface optimized for OpenSCAD code, including basic programming operations, a code writing area, an integrated error log for debugging, and a dedicated code changes list that displays code changes after manual modifications. The AI Assistance panel offers an always-available input chat box where users can request information about their current model or solicit modifications through natural language. An AI feedback panel that structures LLMs responses into three distinct sections: a concise summary of changes, a detailed description of modifications per component, and a code change list. And finally, the History Records panel chronologically saves all the interactions with the system for users to read records and restore to an endpoint. These three components serve an AI verification loop for model understanding and a robust version control system. Lastly, the model panel combines a hierarchical semantic structure that represents the model's internal structure with a 3D rendering panel that displays a model projection from a fixed angle, showing most parts of the model. A11yShape system features a core technique called cross-representation highlight that maintains an active semantic synchronization across different panels. When a user selects a component part in the hierarchy, A11yShape instantly highlights that same part everywhere else. The 3D rendering will visually emphasize that region, the AI panel will speak out a description of that piece, and the corresponding code lines will be highlighted. It also plays a short tone so the user knows the connection just happened. Also, when the user uses keyboard shortcuts to navigate between the panels, like jumping to the code editor, they will be able to land on the highlighted part. Now let's take a look at how Alex, a low-vision programmer, creates a helicopter 3D model using A11yShape. He started by using a long prompt to generate the entire helicopter model at once, but the output was far from what he expected. After recognizing the limitations of his all-at-once approach, Alex decided to build the helicopter incrementally, component by component. First, he crafted the helicopter's body with the prompt and verified the result through AI's description. Then, he added the landing gears. He not only interpreted the generated components through the description, but also identified the discrepancy between the AI feedback and his residual vision. He examined the highlighted code and adjusted the position parameters, while repeatedly using the cross-representation, highlighting to verify changes until the landing gear was properly attached to the body.
The part of the model. Shape or cavity. A11yShape response. AI. Lines 15 to 19. Changed the translation values for rendering the landing gears and adjusted the body rendering call. Port. The part is used in a difference operation, making it invisible in the final model.
To build the main propeller, Alex used the version control feature to iterate on the blade's angles and positions. Finally, he added a decorative ring to the tail propeller with the help of AI suggestions and the use of the hierarchy list with proper code generated. To understand how people use the system, we ran a multi-session study with 4 BLV programmers. Each session lasted for 2.5 hours, including a tutorial and introduction in the first session, followed by a second session that guided the participants to replicate some 3D models, and a final session where they created something on their own with A11yShape. As a result, they created a lot of unique 3D models, everything from rockets and robots to helicopters and circuit boards. From the study, we found that participants worked in small cycles of generating, verifying, and refining with the descriptions provided by the AI assistant. They leaned heavily on the hierarchical navigation and version history to locate and fix mistakes. They really appreciated it when the AI used real-world metaphors, which turned out to be essential for building spatial understanding. And finally, a trust-building process over time was observed. A11yShape explores a new way of supporting BLV people in creative tasks, which also involve a lot of visual and complex operations. For more information and implementation details, please refer to our paper and the project page.